This video will cover section 6.1, law of cosines. The objectives will be to use the law of sines to solve oblique triangles. This means triangles other than right triangles. And here the letters A and S represent either an angle or a side. So the two types of triangles, that we could solve here, actually three types, will be to have two consecutive angles given to us and one of the sides. Or have one angle and then the side in between the other angle. So two angles and one side in the middle. We call that the included side. Or we could also use the same law of sines to solve oblique triangles of the form SSA, which is side, side, and then angle. In this section, we will also explore another way to find the area of an oblique triangle so that you don't have to find the height. Instead of that, we will use a sine function. And then finally, we will apply that law of sines to model and solve real life problems. Because, we all navigate in the ocean. Introduction. In this section, and the next, we're going to be working with oblique triangles, and it's quite easy. So this section and the next one are way easier than chapter 4 and 5. And just to remind you, in chapters 4 and 5, we were only working with right triangles with an angle of exactly 90 degrees. So here we are going to have either acute triangles like this one, where all the angles are acute, less than 90, or we could also have an obtuse triangle. So standard notation, just so you get used to it, we're going to have the angles A, B, C denoted by uppercase letters. So we have here angle A will be here. And the side opposite to angle A will be labeled with the lowercase of the same letter. That is side A. Then we have angle B, which will be here. And the side opposite to angle B will be lowercase b. And then finally we have angle C. And the side opposite to angle C is lowercase c. So you can see that is standard. We're always going to use that. You can also see how it is labeled in alphabetical order. We start here with A, B, and then C. So it is triangle ABC. So to solve a triangle, an oblique triangle, we need to know the measure of at least one side and any other two measures. So just like we explained here, one side and either two other measures like two angles, or one side, a side, and an angle. And okay, yeah, so we cover that. Now in this section, we're going to cover these two items, solving triangles of this form. We're going to use law of sines. So that is what section 6.1 is about. Now, when we get to section 6.2, that will be the law of cosines, like you could see here. And with that law, we are able to solve triangles of this form when you are given three sides and you have to find the three remaining angles, or the three angles. Or there you are given two sides and you are given the angle in between the two sides, which is referred to as the included angle. So an example of that will be you get, let's say this side, you are given A and B, and then the angle that you get is the one in between, which happens to be angle C. So that is something that will be the included angle because it's in between. And also three sides. So that will be next section. So here we have the law of sines, and as you can see here, it is a ratio. Now you don't have to use all three fractions or ratios at the same time. In fact, you're just going to pick two. You're going to use two at a time, and with that you will have something like a proportion, and then you will be able to either solve for one of the lowercase letters, which are the sides, or one of the uppercase letters, which are the angles. And so that just depends on what you have and what are you looking for. So what I'm going to do now is show you how this formula was derived. So you can see here we have an acute triangle. Both of these triangles, acute and obtuse, are considered of the form oblique because they're not right triangles. However, to derive this formula, we're going to trace the height, which it has to be from one vertex and then to the base, and it will have to be perpendicular to the base. So you can see you have a 90-degree angle there. So what I'm going to do now is separate these two triangles from here. So I'm going to call them my pink and my purple triangle. Then I'm going to go ahead and draw them here, but I'm going to separate them. So I have angle B here. We have H for height, and we have side A. And what else am I going to need? That's all I need. And then for the little triangle, the one that I traced in pink, we have here angle A. We have H for height. That is the same blue line that I traced. And then we have here, and I'm going to erase a little bit so you can see it is B. I don't know why my eraser is not working. So that is B. So what I'm going to do next is I'm going to consider angle A and write an expression or an equation that will tell me what sine of A is equal to. And by definition, it will be the opposite side, which happens to be the letter H, divided by the hypotenuse, which happens to be the letter B. So from here, what I'm going to do is solve for H, and you can see B is dividing to H. So if I move it across, it's going to be multiplying. So it will be B times the sine of A. Now I'm going to do the same for angle B, and I'm going to find the sine of angle B. And by definition, sine is defined as opposite. So H over hypotenuse, which will be A. From here, I'm going to solve for the letter H, which is the height. And the A, which is dividing on the right, is going to be multiplying on the left. So that will be A times sine of B. And from here, now we have two different expressions for the letter H, or for the height. And what I'm going to do next is compare one to the other. So it's going to be B times sine A is equal to A times sine A. So if I write B times sine A, I'm actually going to write it up here, B times sine A, and that will be equal to the other expression that we have for H, which is A times sine A, or sine B. And now what I'm going to do is make it look like the expression that I have here. So I will leave my A where it is and the B. Remember, lowercase is to represent the length of the side. And I'm going to take sine A to the right side of the equation and sine B to the left side. So sine A is multiplying to B, and if I want to take it across, it's going to be dividing on the right side. Similarly with sine B, it's multiplying on the right side. So if I take it to the left, it's going to be dividing. And so right there we have the equation that you can see there. Now, similarly, we could derive the same for this other triangle, but we're not going to do it. But the two triangles that we consider will be that one. That will be the one of them, and the other one will be the big one. This is an important skill to have, because sometimes when you do word problems, you do have to draw your own triangles. So just like we could have the side on the numerator, we could also have it on the denominator. And remember, you only use two at a time. So we could say C over sine C is equal to A over sine A. or we could say C over sine C is equal to B over sine B. So as long as you have the same letter on for the side and for the angle, remember one is lowercase, one is uppercase, then you will be fine. But you cannot interchange or mix and match. So just stick to those, and remember you could have this trigonometric expression on the numerator as well, because you're just solving a proportion, so it doesn't really matter. So for example, we have a triangle. It is an acute triangle. We are given one of the angles, which is C, and it will be here, and it's 102. We have one of the sides, well, another angle actually is 29, and we have one of the sides which is 28 feet. So that will be lowercase. Well, actually, I'm going to color that blue. There we go. So on the question, it says find the remaining angle and sides. So first I have to see if I have two of one letter, meaning the angle and the side. So I do. I have B equals 28 feet. So I'm going to use the equation B over sine B is equal to, and since I have the other angle here, 102, for angle C, I'm going to use sine of C, uppercase, and then lowercase c on top. So our goal here is going to be to find the side. Now let's go ahead and substitute what we can. So lowercase b is 28, uppercase B is 29 degrees, and we're solving for C, and angle C is 102. So to solve for C, we just gotta take care of that sine of 102. So the sine of 102 is dividing to C. So what I'm going to do is take that whole expression across. So it's going to go from dividing to multiplying. And that is divided by sine of 29 degrees. And please do not go ahead and cancel it like that. That will be completely wrong. Don't do that at all. Just no, don't do it. What you're going to do is actually enter this whole expression in the calculator. So I'm going to show you how to enter it. So it's going to be 28. Well, I'm going to clear my screen. It is 28 times sine of 102. We close parentheses, and then divided by the sine of 29. Let me just check that's what we wanted. Yes. So we close parentheses, and I just want to point out that we need to have degrees on our mode. If it says radians, or if you're not sure, you need to go to mode and then make sure that the word degree is highlighted. If it is not, let's say that radian was highlighted like that, you could see how the calculator switches here. So for these two sections, we're going to stick to degrees. So you will move with your right side arrow, then press enter to highlight degree. Now we go back to the main screen, and we are sure that we're in degrees. So we have our solution here, 56.49. Let's round to the, I noticed on the homework, they're asking you to round to the nearest hundredth. Well, that means 2 digits after the decimal point, so 56.49. Okay, and this will be the side, and of course the units will be in feet. Now, because we have that side, but remember we rounded a little bit. So to find my remaining side, which is A, I'm going to use what was given to me. So I'm going to keep using this part of the equation. So it's going to be B over sine B. And now I'm going to go ahead and find A and angle A. So A over sine of A. So it's always good to go back to the original ones that were given to you from the question and not the ones that you found in the process because you had to round and so it could just be wrong by a few decimals. So, oh, I just want to check if I enter it right. Yes, I did. Okay, so, and also, we don't know what angle A is equal to. However, that's pretty easy because you should know, and if you don't know, it's okay. The sum, the addition of all interior angles of a triangle is equal to 180 degrees. It cannot go past that. So from 180 degrees, we're going to subtract the two angles that we already know, 102, and we're going to subtract 29 degrees and degrees. The answer is 49 degrees, so that is what A, uppercase A, will equal to, 49 degrees. And remember to find, we were asked to find all remaining angles and sides. So A is equal to 49. Now I will be able to substitute that 49 here in this formula. So we're going to do that on the next page. So again, I'm going to write the formula. Remember to write these formulas on your formula sheet. You will definitely need them. So we're going to substitute lowercase b with 28 feet. And then angle B is 29 degrees. So I'm going to substitute uppercase B with 29 degrees. And then I'm going to have A, that's what I'm solving for, the side. And I'm going to divide by angle uppercase A, which is 49 degrees. So just like we solved the other question, or for the other side, we are going to solve for A here on the equation. So you can see that sine of 49 is dividing to A. So we're going to have 28 times sine of 49 and divided by sine of 29. And remember, we cannot cancel sine. Don't ever do that. That is completely wrong. So don't do it. Just don't. So A is going to equal 2, and we're going to enter that on the calculator. So it's going to be 28 times sine of 49, close parentheses, and then divided by the sine of 29, close parentheses, enter. And again, we're going to round to the nearest hundred, or 2 digits after a decimal point. So this is going to be 43.59. And the units are feet. And so that's just how we solve the triangle. We have all three of them. We have, I forgot, 43.59. We have all three sides, and we also have all three angles. So that's how we know we're done. Okay, so within this section we have a special case, which is called the ambiguous case, and that is whenever you are given two sides and an angle. And this is not the included angle, so imagine you are given two consecutive sides and then you are given the next angle. So in this case, you're actually being given the, let's pretend this is lowercase a, so this will be angle A, the one opposite to one of the sides. So whenever you have an opposite angle given, you have three cases. Well, you could have one of these three cases. One is that no such triangle exists. It's just impossible based on the measurements. Second is that you have one solution, one triangle exists. And the third one is that two distinct triangles could satisfy the conditions. And that is just because if you recall how the sine function is made, let's say the sine of 45 degrees, actually no, let's use my favorite angle. The sine of 30 degrees, which you should all know, is 1/2. But also the other angle for which the reference angle is 30 degrees, and I'm talking about an angle that goes 180 minus 30, so that will be 150. So the angle of the sine, actually, not the angle, the sine of 150 is also 1/2. So that is where the two distinct triangles will come from. But imagine if one of the angles is so obtuse, like close to 180, the other two angles are going to be very small because the addition of all three cannot go past 180. So those triangles are a little weird looking. So here's a graph of all the cases that we have. So the way you can compare, and I actually included some homeworks like this ones on the homework, you will look at what you're giving. Remember, we're talking about a triangle with two sides. I'll just draw it here again. So you are given two sides and then one of the opposite angles to one of the sides. And so given that, h is the height, remember? So this is similar to how we derived the law of sines from the beginning. If you recall, we had two triangles and we had two expressions for the height. So by using that, h will be found by multiplying b times sine a. And in this case, you could see how the two letters, the side and the angle, are not the opposite or the corresponding ones. So we have different side in the angle that is not opposite to it. That is how you will find h. So if you compare one of the sides, side A, to the height, and the height is smaller, sorry, the side A is smaller, or the height is larger than side A, then that is when you will have no triangle. There will be no solution. And you can see on the picture that the sides do not connect. It's just physically impossible. Now, if you have A equals H, this side, then we know that H for height is perpendicular to the base. So this is actually one solution, and this just happens to be a right triangle. I know it says acute here, so I'm still confused about that. So I know we shouldn't assume it's a right triangle, but the fact that A equals H is telling me that. Then we have another case with one solution, and that would be if one of the sides, the one that is not opposite to the angle given, actually the one opposite to the angle given, side A, is greater than the other side, the side that is not corresponding with the angle. So if it's greater than or equal, then you have an acute triangle. So just like the one we solved previously. Now, the case with two triangles, that occurs whenever the side A here is less than side B. You could see that here. It's pretty obvious that A is less than B. But also A is greater than H, is greater than the height. So that is when we could have those two cases. And so just to trace where those two cases will be, one could be like this big triangle that you see, and the other one could be this little triangle that you could see here. So those will be the two solutions. One is the big triangle, the other one is the little triangle, the one in pink and the one in purple. Then another case where you could have no solution at all is if side A, and make sure you have your notes when you do your homework, because you do have some of these questions. Side A is less than or equal to side B. So it's not only less than B, but also we have that condition with H. We don't have the condition with H, so we have no solution in this one. And you can see that it's because side A is just too short to even form a triangle. Okay, and then finally we have another case which is 1, and that will be if A is the largest side and it's larger than B. And you could see that here. So we have 2 cases where you have 1 solution, actually 3. And we have acute triangle, and then we have here 2 obtuse triangles. We have 2 cases where we will not have a solution. They're right there. And then we have 1 case where we could have 2 solutions, and that will be this one here. So make sure you do have that on your notes. So for example 3, we're going to solve the triangle, which means to solve a triangle is to find the remaining side and angles or whatever is missing. So we are given 2 sides and an angle. So let's see, we have side A is 22 inches, and then we have side B is 12 inches, and we have one of the angles that is opposite to one of the sides, and for that reason the letters match, just uppercase, lowercase. So we have angle A is 42. So we are going to work with that, and we know that we are only going to get 1 solution because A, just like it says here, A is greater than B. We could see that clearly. A is greater than B. And if we go back to this table, A is greater than B, we're going to have this case. Yes. A is greater than B. Yeah. Okay. So it kind of looks more like an obtuse. No, I think it would be more like this one, the obtuse. I thought for a second it could be this one, but if you notice here, all 3 angles are acute. And then for this one, for obtuse, 2 of the angles are acute, and then we have one that is obtuse more than 90 degrees. So that's gonna be angle C. Okay, so let's go back to this. So we're gonna use the 2 things that we do know, which is side A and sine of angle A, and the other thing that we were given was B. So let's go ahead and find angle B first by using this equation. So by substituting, lowercase a is 22, sine A is sine of 42 degrees, B, lowercase b is 12, and then we're looking for uppercase B. That is our goal, to find that angle right here, angle B. So what I'm going to do is take sine B to the right side, so it will be multiplying. So 22 times sine B divided by sine of 42. And on this side we have 12. So now sine of 42 degrees is dividing sine B. Remember, this is what I'm trying to solve for. In fact, I'm going to have to first isolate sine of B and then take sine inverse. So the sine of 42 degrees is dividing to sine B. So I'm going to take that sine of 42 degrees across, and it's going to be multiplying to the number 12. And remember, we cannot multiply 12 and 42 because it doesn't make sense, but also they're not the same units. 12 is in inches, 42 is degrees, and 42 does not go away from sine yet. And what else do we have? Okay, so yes, we have that. Now, we're still trying to isolate sine of B. So you can see here how 22 is multiplying to it. So to solve for sine of B, is going to be 12 times sine of 42 divided by 22. And then remember how our goal is to solve for the angle. So to solve for B, we are going to take the sine inverse on both sides. Of course, on the right side is going to disappear or cancel out because they're inverse operations. So we're only concerned of what's happening on this side. So let's go ahead and enter that on the calculator. Okay, so a sine inverse. Now remember to find your sine inverse. You can see it here. It's in blue, so I'm going to use the second function, sine inverse. And then inside there, I'm going to go ahead and open another parenthesis to include the numerator, which is 12 times sine of 42. So 12 times the sine of 42 degrees. I'm going to close that with double parentheses. One is for the degree and one is for the numerator. The one here for the numerator is closing this one here. And the first parenthesis is for sine inverse. Then after that, I'm going to enter divide. And then I believe we're dividing by 22. And I'm going to close the parentheses one more time to close the first one that I opened, the one right next to sine inverse. And remember, we must be in degrees, so we're here, we get 21.406. If we round to the nearest hundredth, it will be 21.49. So angle B is 21.41 degrees. Now that we have two of the angles, it's very easy to find the third one. So it will be 180 minus the first angle that was given to us, angle A, which is 42. And then we're going to subtract the one that we just found, angle B, which is 21.41. And this is going to give us the missing angle, which is C. So we get that C, angle C, the one here, is equal to 116.59. I just want to make sure I enter everything correctly. So I had to enter sine inverse of 12 times sine of 42 divided by 22 sine inverse. Okay, so yes, it is correct. So yes, and you could see that this angle is obtuse, definitely greater than 90. So now the only thing that is left for us to find is going to be side C. So for that, we're going to use the, I'm going to write it with a different color. So it's going to be side C over sine C. And then we're going to have here, let's use again the tool that were given to us. And what I'm going to use is A for angle and for the side, because those were the ones that were given to me. So it's better to go back to the originals because those are not rounded. So you know how WebAssign is just so picky and you don't want to get into those issues. So for side C, that's what we're looking for. Angle C, we estimated that to be at 116.59. And we have side A was 22, that was given to us. And then the sine of angle A, which is 42 degrees. So to solve for C, we will have, I'm going to need a little more space. So C is going to equal to 22 times the sine of 116.59 over sine of 42. So let's go ahead and type this in our calculator. So 22 times sine of 116.59 divided by the sine of 42. And we get 29.401, so we're going to round this to 29.4 or 29.40. Same thing. And the units for this one were inches. And so that is the answer to this part, to lowercase c. Let me just write it here. So now we have all three angles, we have all three sides, the lengths of the sides. So we're done with that problem. So before we move on, I just want to point out that here this statement that says acute is not referring to the triangle but to the angle. So angle A is acute. So and so in every single case it's referring to the angle, not to the triangle. So here A is obtuse because it's more than 90 degrees. And the triangle that we have here is still a right triangle. So I was right about that, but confused about the triangle, or the word acute, that of the notation. Yeah. Okay, so if you recall how we derived the law of sines from the beginning, we had the two triangles. We had a little one in pink, and so if we try to calculate that, it's a right triangle, so we are able to use not the law of sines, but just the sine function. So sine of angle A is equal to opposite, which is h, over hypotenuse, which is b. And so if we solve for h, we will get that h is equal to b times sine A. So that is where this expression is coming from. So recall from the objectives, one of those was to find the area of an oblique triangle, which is not a right triangle. So when you were in elementary or middle school, I don't know, you probably learned the formula, I hope elementary, base times height divided by 2, or remember, dividing by 2 is the same as multiplying by 1/2. 1/2 times the base times the height. So back then, you were probably given right triangles, or you were given the height to substitute. And then maybe perhaps in high school, you learn how to find the height of a triangle by using Pythagorean theorem, perhaps. So in this case, instead of worrying about finding the height, we're going to use an expression such as that one. And on the next slide, we're going to go ahead and show you, I'm going to go ahead and show you how we will derive that. So if we consider still this triangle here, the base is C. So we're going to substitute base with the letter C. And then the height is going to be substituted with the expression that we have here for height, b times sine of A. If we just, change it so it is in alphabetical order, it will be 1/2 times B times C and then sine A. So I want you to notice something. We're using lowercase b and lowercase c, and then what letter is missing here? A, but we're using it as the angle for sine A. So that is the same case with the other two. We have side A, and then here we have side B. So then the angle must be the other letter that we don't have. In the third variation, we have side A, side C. So therefore, the angle must be the letter that we don't have the side for. And so all three of those formulas will give you the area of an oblique triangle. So a triangle that is not a right triangle is either an acute triangle or an obtuse triangle. And the three formulas, three variations are also listed here. You can see they are the same. Make sure you have this formula handy with you. And let me just show you why when you have a right triangle, the formula just becomes base times height. It's very easy because sine of 90, so if this is your 90, sine of 90 based on a unit circle, it will be located here, 90 degrees. So the coordinates at that point of the unit circle will be 0, 1. And remember, the second coordinate gives you the sine value. So sine of 90 is equal to 1. So if we substitute this with a 1, we will just get B times C. So that's why it works. Okay, so we're going to find the area of the triangle here. And so we see that we have two sides and we have the angle in between them. So let's see, we have side A. Well, first of all, we need 1/2. We have side A is 90, and then we have side B is 52, and then we have angle C. So we're going to need sine of angle C. So let's go ahead and substitute here. So A is 90, and B is 52, and then we have sine of 102 degrees. So we're going to enter that on our calculator. So I'm going to just clear the screen quickly. So I'm going to enter 1/2 in parentheses. That is the right thing to do, or you can enter 0.5 if you want. Then we need the two sides, 90 times 52. And then we need sine of the angle that was given to us, which is 102. And so we get 2,288. We're going to round it to 0.87. So 2,288.87. And because we're talking about area, the units will be square meters or meters squared. So that is the answer to that question. Okay, the next one, this is why I was saying that the real life application is about a boat. So I know not all of us are, used to navigate boats, but you never know, it might happen. So this is a boat race. The problem is about a boat race, and we're going to solve it by using the law of sines and parallel lines. So we have the course for a boat race starts at point A. So we start here. That's our starting point. Then the boat proceeds in the direction south 52 west. So just to show you what I'm going to do, I'm going to trace the north-south line and then the east-west. And so we're going to go south. So it will be here, south and then 52 degrees in the west direction. So I'm going to the left. So that will be the bearing that comes from there, south 52 west, to point B. So now we're moving to another point here. Then from there, the direction changes to south 40 east. So if I trace from that point again, the north-south line and the west-east line, and it's saying south, so it will go south and then 40 degrees to the east, so I move to the right. So that will be the bearing, and from there the boat will travel to point C. Now the question, and then it goes finally back to point A, because it's a race, so the course, it just happens to be a triangle. And we're also told that point C, it lies 8 kilometers directly south of point A. So if this is our north-south line, it will be exactly 80 kilometers below. So point C is 80 kilometers south of point A. That's how we know that. So now let's go ahead and label our sides, and remember we must use the angles. So the side opposite to angle A will be here. The side opposite to angle B will be here, so that is the 8 kilometers, lowercase b, and then the side opposite to C will be here. Okay, now I'm going to read the last sentence. Approximate the total distance of the race course. And so what we need to find is the perimeter of this triangle, which is going to be the addition of the sides A plus B plus C. And of course, we only have one of those. But we know the angles, and so the idea is that we use the law of sines to find the other sides. So we're going to use parallel lines. So let's consider this north-south line one of the lines. I'm just going to extend it here. And then we're going to have the north-south line over here. Now, how do we know that those are parallel? Well, because they're north-south lines. That's why. And all of those are parallel. From here, first I'm going to trace a transversal. And when I say a transversal, it's a line that crosses both of those parallel lines. So like that. Oops. So now I'm going to label some points. Here we have angle A. Here we have this intersection here, that is angle B. And let's see, what else do we know? We know that the angle here, you can look at the drawing, is 52 degrees. So because we have two parallel lines with a transversal going across both, the angle that I'm drawing here happens to be the same as 52. Why? Because they're called interior alternate angles. So this one is also 52. Now I'm going to draw the other transversal, which what I mean by that is this line here. But I'm going to extend it past the parallel line. So I'm going to do that here. And now I'm going to label the points according to my triangle. So this is C. And then I also have this little angle provided to me. So the angle came from the bearing, so it's here, 40 degrees. And we need to find, I'm going to erase all the drawings that I have here. This is so messy. Okay, so remember, we need to find this angle here and also this one, so that we could find the sides, the opposite sides. So from the fact that we know that this angle is 52 and this one is 40, and also we do have here a straight line, the north-south line is a straight line. So if we consider the angle, the straight angle here, that should add up to 180. So to find the angle B, I will have to calculate 180 minus 52 minus 40. And that will give me what? 88 degrees. So that's what this angle is, 88 degrees. That is angle B, uppercase B. Now, to find the remaining angle, we could just say 180 minus angle A minus angle B. That will be completely valid. So 180 minus 52 minus 88. And we're going to get 40. Now, that is not a coincidence, because if we consider, again, the two parallel lines, and this angle here is 40, then the angle here is the alternate interior for this particular transversal, the one in pink. So that one is also 40 degrees. So that's how I knew it. I can't add or subtract. Well, actually I can add but not subtract. So now we have all three angles, right? So that is, so now we need to find lowercase c. And let's go ahead and let's use side B, because that was given to us. And so we're going to go ahead and substitute. So side C is what we're looking for, but we know the angle is 40. And then for side B, we know is 8. We have here sine of angle B, which is 88. So then for side C, it's going to equal 8 times sine of 40 divided by the sine of 88. So let's enter that on our calculator. 8 times sine of 40, close it, divide it, sine of, I forgot, 88. And that will give us 5.145, so we're going to round it to 5.15. 5.15, and the units are kilometers. So now we have one side left to find, so that will be A over sine A. And I will also like, because we rounded when we found C, I would like to stick to this form, to those units, lowercase b and uppercase B, because they're more exact. They haven't been rounded. So substitution for A, that's what we're looking for. Then sine of A, angle A, where I said angle A is here, is 52. And that is equal to 8 for lowercase b, sine of 88 for uppercase B. So then A is going to equal to 8 times sine of 52. Remember, sine of 52 is dividing here, so on the right side it will be multiplying. So sine of 88. And if we enter this on the calculator, we will be getting 6.31. Now remember, the question was to find the length of the race, or the perimeter of the triangle. So That makes sense that we add them. So this is like B plus A plus C, and we get 19.46 kilometers. And so this is the end of the video.